Okay, and here's part 3 of the Lab 7 videos. So the scenario that you've just looked at is what's called a partial digest, which is when essentially when one of the enzymes ends up missing one site on some of the plasmids. It's going to be most likely to happen if you have a particularly high plasmid yield, because EcoR1 is very good at its job, but if you have a lot of plasmids in there, it just might not be able to get to all the sites. So because the enzymes aren't perfect, they're not 100% effective. So a partial digest is what happens when EcoR1 or BAMH1 cuts some but not all of the sites. There's another scenario, usually going to be due to pipetting error. What if whichever enzyme it is didn't cut any sites at all? In both cases, you can figure out what's going on by looking at how bright the bands are and comparing them with other lanes. So hopefully you've seen that with a partial digest, you'll end up seeing a band higher up that's fainter than bands lower down, when a band that's higher up should actually be brighter. And that the total size of the linearized plasmid can be confirmed by the other digest. Your TA will go over that exercise with you. You can also tell by comparing to other lanes based on the brightness of the bands whether you've got a scenario where none of the sites were cut. And let's look at that for a minute. So our plasmids are circular. Um, the ladder that we have is linear. And so we know that p-blue script is 3 kb, but we're comparing that to a linear standard. And circular DNA is shaped funny. It's not going to run the same speed as linear DNA is. And if we look here at the cut lane, that's just p-blue script that's been digested with EcoR1, we can see that it's running at about 3 kb. If we look at the uncut lane, which in this case was not treated with any enzymes at all, again, it looks kind of weird. We've got 2 bands there, which shouldn't be happening because it's p-blue script that hasn't been cut with enzymes. It's all the same. It shouldn't show up in 2 places. We can understand maybe why circular DNA and linear DNA might run differently, but circular DNA and circular DNA also running differently might be a little unexpected. And the reason for that is that even circular DNA can have more than one shape. So normally, plasmids in E. coli are kept supercoiled, which is what we're seeing over here on the right. They essentially take this circular piece of DNA and twist it up as tightly as they can, largely for reasons of space. E. coli are all about saving space. Um, but sometimes just through sheer random accident, you get a nick in one of the 2 strands of DNA, and the tension in that supercoiled circle unwinds. It spins out, oops, and becomes just a fully relaxed circle. So these stages you don't tend to see a lot. They mostly only happen as it's progressing from one to the other, either a relaxed circle that's being supercoiled or a supercoiled plasmid that has been nicked and is relaxing. And so you can see, if we compare the 2 end possibilities, why you could have circular DNA that might run at different speeds, because this supercoiled plasmid here at the end is essentially a shorter, slightly thicker line. So it's actually able to run faster than a just linear 3 kb piece of DNA, because it is, again, it's thicker, but it's effectively shorter. Whereas the relaxed circle all the way over here on the left, it's going to be very difficult for that to squeeze through the small pores in a gel. So that's why we see nicked circle running slowly and supercoiled plasmid running faster. And the fact that the plasmid is normally supercoiled and only becomes the relaxed circle, the nicked circle, if it's taken a little bit of chemical damage, which the cell can fix. This sort of thing happens all the time. But that's why we see the difference in brightness there. So again, it's a scenario where you've got a high band that's really faint. But you can tell in this case that what's going on here is that it's undigested plasmid because nothing is running at the right size. Uncut p-blue script, whether it's cut or not, is 3 kb. And if we look at the uncut lane, it's just one sample. It's running at 2 different sizes, neither of which are 3 kb. That tells us this is undigested plasmid. I want to distinguish between undigested plasmid and partially digested plasmid. Those are very different things. Don't call one of them the other on the post lab or you'll be wrong. It's partially digested if some but not all of the sites have been cut. It's undigested if none of the sites have been cut and it's still circular. So remember that distinction, please. And now I'm going to stop this recording, and the next one is going to address things we might see with our PCR products.